Algebra lesson 4-4. Continuing our work with graphs and any pieces of the graphs, we now have something that we know as slope. From here on out in algebra, we will refer to slope as M, the letter M. We call the slope rise over run. Rise represents the up and the down, and on our graphs, our coordinate planes, when we go up, the values are positive. When we go down, the values are negative. When we run, that's left and right, left values are negative and right values are positive. So rise over run. Big mistake, people accidentally put the run over the rise. Got to watch that. All right? So rise over run is our slope. Here's a very typical look for rise over run. A fraction 4 over 3. I realize that's improper. Resist the urge to make that 1 1/3. If it's 1 1/3, it's a lot harder to deal with rise and run. So this, because it's a positive 4, is telling us we go up 4 places. And this, because it's positive 3, is telling us we go right 3 places. So our graph is just like stairs. If we have a point here and we go up 4 and right 3, it'll keep doing that forever. Up 4, right 3, up 4, right 3, up 4, right 3. It will continue as stairs for eternity. All right? Another rise over run situation to think about is what we would call the change in the y over the change in the x. So here's a coordinate on the graph and here's a coordinate on the graph. Certainly one of the points is higher than the other. This point is lower than this point. To get from this point to this point, I have to go up. That's a change in my y. How much did it go up? That's the change. Once it goes up, it's still not in the same location as over here, so it has to run. It has to have a change in the lateral movement to the right. So that's the change in the x. We have a formula that gives us slope. And this is the absolute quintessential piece that you must know if you want to find the slope given two coordinates. We say these little numbers as subnumbers. So this would be pronounced y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And all that means is that you have two coordinates, and every coordinate is made up of an x and a y. So because there's two coordinates, we want to differentiate between the two and make sure we're talking about this is one of the coordinates, x sub 1, y sub 1, and this is the other coordinate, x sub 2, y sub 2. So here's how it works. We have two coordinates here. Don't forget y sub 2, oops, I wrote the wrong one. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Make that a little bit off the way. Good. That's always equal to our slope. Now you can label this x sub 1, y sub 1. You could call this x sub 2 and y sub 2. That's perfectly legal. What you cannot do is put all the x's together like this. You can't have x1 and x2 together. That's not what coordinates are made up of. All right? And you can't put the sub 2's and the sub 1's together. That's not okay. You want the sub 1's to be together and you want the sub 2's to be together. And you want each coordinate to be made up of an x and a y. So what you could do if you wanted, though, is you could put them here. There's certainly nothing wrong with labeling this the sub 2 values. That doesn't matter. Call them whatever you want. So if I'm using this formula, I always start off by drawing a line. And then after I've drawn the line, I then put two subtraction signs. One there and one there. And that means there's 1, 2, 3, 4 places that I have to put numbers in the correct spot. It's nice that there's 4 places because there's actually 4 numbers. I just got to put them in the right locations. According to the formula, y sub 2 needs to go right here. Y sub 2 is 0. According to the formula, y sub 1 needs to go right here. Y sub 1, oops, somebody didn't catch this for me. Those need to be backwards. There we go. Y sub 1 is 2. And then down below, according to the formula, is x sub 2, which is 5. And x sub 1 is 0. And all you have to do is do your math on the top and your math on the bottom, and you will have the slope. 0 minus 2 is negative 2. 5 minus 0 is 5. All right? Now somebody might say, yeah, but Mr. Corey, at the beginning you had it labeled differently. At the beginning you had this one labeled x sub 1, y sub 1, and that x sub 2, y sub 2. That's fine. Go ahead and flip it around. If you flip these two around, what's it going to do on top? It's just going to flip the top around. and you'd end up with this. And if you flip these two values around as far as your labels, what will it do down here? It'll flip that around. And you'll end up with 2 minus 0, which is 2, and 0 minus 5, which is negative 5. And remember, if the negative's on the top or the bottom, it's the same. Just can't make it both. That wouldn't be the same. So we have slopes of some different types of lines. The other day we were talking about lines, and we said anytime we have x and y, we know the line is diagonal. Anytime we have just x, that's it, just x, we know we're going to have a vertical line. And anytime we have just y, no other variable, just y, we know we have a horizontal line. So here's a couple situations where the lines are diagonal. You read graphs from the left side to the right side, just like reading a book. And as you look at them from the left to the right, it appears as if the graph is going up. That means it's positive. As you look at it from the left to the right, it's going down. That means it's going to be a negative. These two graphs will involve x and y. If you see x and y in an equation, you know it'll look something similar to one of these two, depending on the slopes. But I also mentioned that we had a horizontal line. When you have a horizontal line, this means you only have y. This would be only y in that problem. Horizontal lines. Think about your rise over your run. In terms of rise over run, horizontal lines don't go up at all. They have no rise. They stay flat. The run can be any number. It could go right 2, it could go right 6, it could go right 8, it could go left 10. It doesn't matter. You can pick any number you want to go down below. Maybe it goes from here to there. You know, if that's the case, 0 divided by 6 is 0. It's going to equal 0. Any horizontal line has 0 slope. Now that makes people think that when the line's vertical, it's also going to be 0 slope, but it is not. It's actually what we call undefined. Now, let me clean that up. Rise over run. In this case, your rise could be anything. Could go from here to there. Maybe it goes up 7 units. But it doesn't go left and it doesn't go right, so the run is 0. You cannot divide by 0 and get an actual value. That's why we call it undefined. These are going to be only x. Only y, horizontal, 0 slope. Only x, vertical, undefined slope. Undefined is not 0. Undefined is not a value. Alright, this last example, I just want to point out, by the way, too, that we were talking about rates and ratios the other day, and that when we are comparing two different quantities, that's a rate of change, comparing two different quantities, and rise over run is comparing two different quantities, which means this is actually a rate. Just like the rate of speed is miles per hour, two different quantities, this is two different quantities of rise and run. This next and last problem are the more complicated kind that you'll face. If you'll notice, this time I'm giving you the slope, giving you a coordinate, but you're missing one of the coordinates pieces. You know the x value, but you don't know the y. I would recommend, in this case, when you go to label these two coordinates with your sub numbers, always label the one you don't know with the sub 2. So if you label that as y sub 2, then this has to be labeled x sub 2. And if those two are x sub 2's and y sub 2, this has to be x sub 1 and y sub 1. Now you can use your formula. A line with two subtraction signs equals. It always equals the slope. The slope right now is negative 2, so that's got to go there. According to the formula, y sub 2 should go here, which means I'm going to put my y that's unknown right here. I want the unknown to be in this spot so I can play the shuffling game easier and get the y's value. If it were mislabeled up here with x sub 1 and y sub 1, I could still do it. It would just require more work. Here goes the y sub 1 value, which is 5. X sub 2 value, which is 3. X sub 1 value, which is 1. From this point, there is definitely a math problem that you can do to simplify this. So I now have y plus negative 5, because I'll change that to plus negative. And on the bottom, I've got a positive 2, still equals negative 2. If you would like to get rid of this fraction, you must do the inverse. which would be to multiply by 2. What you do to one side, you must do to the other. Now these 2's cancel out. Y plus -5 now equals -4. And your last step is to add 5. And you get y equals 1. Now it will not take you very long, but you should check that answer. If you put 1 right here, 1 plus -5. You've got 4 more negatives. 3 minus 1 is 2. -4 over +2 equals -2. It in fact works. So that's a little trickier, but you've got an algorithm now that you can apply toward it. Develop some number sense, look for patterns and similarities between problems, and what we do to one maybe wouldn't work with another problem.